Hello students, today we are going to discuss the distribution system of water. Now the distribution system is generally classified into four parts, that is the dead end system, grid iron system, circular or ring system and the radial system. Now we can see one by one each and every type of distribution system in detail, starting with the dead end system. Okay. Now the dead end system is the one in which the main supply pipe which originates a number of sub-main. Okay, there is one main supply pipe from which originates a number of sub-main, and each sub-main then divided into several branch pipe called lateral. Now in dead end system, along the center of the whole area we just provide a main pipe. Okay, and from that main pipe we generally connect the sub-main pipe, and at the junction of main and sub-main we need to provide a cut-off wall to regulate the flow of water. Okay, now from the sub-main we need to connect the various houses with the help of branch pipe, and from the branch pipe we can send the water to various households. Now one problem is there, that at the dead end of this system water stagnation will be a very difficult problem. Okay, it means that if water will stagnate at that dead end, then it will create pollution of that water. That will be the disadvantage of dead end system. Okay, now the advantages of dead end system: lesser number of cutoff wall is required, cheap and economical, shorter pipe length and easier expansion. Suitability: generally it is used for old towns and cities with irregular and unplanned development. Okay, now we can see the limitations of one by one each and every limitation in detail, starting with the first limitation, that is considerable area gets affected during repair. Now suppose that if this submain is under repair work, then what will happen? All the houses which will be present in this portion will be affected because of the repair of this submain. That will be the limitation of dead end system. Next one be the water stagnation at dead end leads to pollution. We had already discussed it. Next one will be the water rate of supply cannot be increased in case of fire breakdown or fire breakout. Suppose that if there will be a fire breakout in this portion. Okay, now we have only one path of supplying water, that is only this way. So there will be a limited amount of water for the extinguishing of that fire. So at the time of fire breakout we don't have enough amount of water for extinguishing that fire. Similarly, if some house will be there in that portion, and if we want to connect it with that branch pipe. Okay, now this pipe is of very large length. Okay, so the pressure in that pipe will be very less, that is less successful in maintaining satisfactory pressure in the remote part. If any house will be at a very large distance, then in that pipe there will be very less pressure, so that it will be less successful in maintaining satisfactory pressure in the remote part. That will be the dead end system. Clear to all? Now next will be the grid iron system. Now in grid iron system we generally provide a main pipe along the center of the area. From the main pipe we generally connect the sub mains, and at the junction of main and sub main we need to provide the cutoff walls like this. Okay, now suppose that there will be a house. Now in that house the water is supplied from two mains or from two main pipes. Okay, now one submain is there and another submain is there. Now from both this submain branch pipe will be there which is connecting that house. Okay, now in grid iron system pressure will be high as compared to the previous system, that is the dead end system. Clear to you? Now suitability: it is suitable for well planned city. Generally this type of system is constructed in well planned cities. Okay, Now the advantages, since water reaches from different directions, sizes of pipes get reduced. If water is coming out from different direction like this, so the size of pipe gets reduced. Very small area gets affected in case of fire breakout. Suppose that if this pipe is under repair work, then we supply the water by that path to that house. Okay, so very less area gets affected in case of repair. Now next one will be the due to free circulation. Here the free circulation of water will be there. Due to free circulation of water, water cannot be polluted, as in the case of dead end system, in which the water stagnation will be a very severe problem. Okay, now more water can be diverted in case of fire breakout. Suppose that in this house, if fire breakouts takes place, okay, now we need to send the water to that house, so we just stop the supplying of water to that zone by just closing that walls, and we just open that wall and supplying large quantity of water from this sources, like this and like this. So at the time of fire breakout, large amount of water will be available for extinguishing that fire. Clear? Now the disadvantages, more length of pipe and larger number of wall. It is clearly seen from the picture that more number of walls will be required and larger number of pipes or larger length of pipes will be required. If larger length of pipe and larger number of wall will be required, then it will be a costlier process and its design is very difficult. Clear to all? Now we can move to the next system, that is the ring system. Now ring system is almost same as the grid iron system. The only difference is that in the outer periphery we had provided the main pipe, and from that main pipe we had connected the submains, and with the help of submain we had supplied the water to various households. So in this process the pressure is high as compared to grid iron system, as well as the amount of water during fire breakout will be more as compared to grid iron system. So advantages and disadvantages is same as that of grid iron system. That is all about the ring system. Moving to the next, that is the radial system. Now the area is divided into small distribution zones, and in the center of each zone a distribution reservoir is provided. Now suppose that this whole area we need to cover. Now we had divided this whole area into number of zones, that is like this, and in each zone we had just constructed a storage reservoir. Now we supply the water to each storage reservoir with the help of some main like this, and from this storage reservoir we can send the water to various households in radial manner. Okay, now that will be the radial system of water supply. Clear? Now it is generally suitable for cities having radial roads, and it ensures high pressure and efficient water distribution. Clear to all? That is the radial system of water distribution. Now minimum pipe size will be there, that if town with population up to 50,000, it means that if a town is having population less than equals to 50,000, then the diameter of main pipe which will be used there is of 100 mm diameter, and if population is greater than 50,000, then diameter will be increased up to 150 mm. So we use 150 mm diameter pipe if population is greater than 50,000. Clear to you? Now the system of supply, we all know that there will be two system of supply. One will be the intermittent system and second one will be the continuous system. Okay, now in intermittent system water is supplied to various households for a particular interval of time, that is for 1 hour or for 2 hour. For 1 or 2 hour the water supply will be there, but in continuous system 24 hours water supply will be there. Okay, that will be the system of supply. Now if we just ignore the leakage problem, then the losses is very high in intermittent system as compared to continuous system, and if leakage is also considered, then losses in continuous system is high as compared to the intermittent system. We had already discussed it in the sources of water and water demand. Okay, now the equivalent pipe method. Now we had two types of method, that is the equivalent pipe method as well as the Hardy cross method for the distribution of water through various pipes. Now we had already studied this topic in the fluid mechanics, that if we want to remove or if we want to replace like this, suppose that we have one particular length of pipe, that is L1, L2, L3, and it is having diameter D1, D2, D3. Now if we want to remove this whole length of pipe with a single hydraulically equivalent pipe, then what will be the formula? That will be equals to L equivalent upon D equivalent to the power 5 equals to L1 upon D1 to the power 5 plus L2 upon D to the power 5 plus L3 upon D to the power 5. Now from this equation we will compute the length of equivalent pipe as well as diameter of equivalent pipe. Okay, now that will be the equivalent pipe method, and in this method the equivalent pipe is one which will replace a given system of pipe with equal head loss. Okay, that will be the important concept, that is with equal head loss for a given flow. Okay, now next will be the Hardy cross method. Now we want to calculate the amount of water flowing through the various pipes by Hardy cross method. Now following three laws are applicable when we generally use the Hardy cross method, and what will be the three laws? First law will be, in each separate pipe or element comprising the system, there will be a relation between the head loss in the element and the quantity of water flowing through that pipe. Okay, so there will be a relation between the head loss, that is HL, and the quantity of water flowing through that pipe, that is Q. Okay, now the next one will be the, at each junction the algebraic sum of quantities of water entering and leaving the junction is 0. It means that at each and every junction of pipe the quantity of water entering and leaving that junction will be 0. The algebraic sum of water entering that junction and water leaving that junction is 0. Now next will be the, in any closed path the algebraic sum of the head loss in the individual element is 0, that is summation of head loss equals to 0 in any individual path or any closed path. Clear? Now we need to determine from here the modification factor, that is delta q, and it will be equals to minus summation of rq to the power n upon summation of nrq. It will be equals to summation of nrq. Now for the calculation of flow through each pipe by Hardy cross method, we need to find modification factor and we need to solve the question till modification factor delta q will not be equals to 0. Clear? Now apparatus in plumbing system which we need to discuss. Now suppose that this is the water main of your society. This is the water main of your society. Now here your house pipeline will be at this level. Now you want to connect this with the help of society main line, for which you need to put a hole on the main pipe, for which you need to pay an amount of rupees 10,000 to the society. Now if you pay that much high amount to the society, then you need to connect it with the very high material so that it cannot break throughout the life. So that material is known as ferrule and it is made up of brass. Okay, now we generally construct or we generally connect a ferrule with the main pipe, and from that ferrule we generally connect a gooseneck pipe, which is a flexible pipe made of lead of 75 size, sorry, of 75 centimeter size. Now from this gooseneck we generally connect the GI pipe or the galvanized iron pipe, and from the galvanized iron pipe we generally connect a stopcock which is generally used for regulating the flow of water in the household, and from that stopcock we generally connect a water meter which is used for measuring the amount of water used in the house. That is the apparatus in plumbing system. We will see each and every type of plumbing system in detail, starting with the ferrule. Now, what is ferrule? It is a right angled sleeve made of brass. I had already told you that we need to connect a very high material or very strong material with the water main so that it cannot break throughout the life of the structure. Okay, so it is a right angled sleeve made of brass. It is joined to the opening drilled in the water main with the plug. Here a plug is provided for the inspection purpose of this ferrule. Now a ferrule is used to connect the water main to the gooseneck. Now what is gooseneck? Gooseneck is a flexible pipe like this. Okay, it is generally made of lead and it is of generally 75 centimeter length. Clear? Now next will be the service pipe, which is generally of galvanized iron pipe of nominal size, that is internal diameter less than 50 mm. It is generally laid below ground level. It supplies water to individual building through the water main we already had seen in our life, that is the galvanized iron pipe. Okay. Now next will be the stopcock. Stopcock is generally used for the regulation or to regulate the flow of water into the house. So it is provided before the water meter if water meter is provided in that service line. Okay. Otherwise it is connected at the end of the service pipe and close to the boundary wall of the premises in an inaccessible position. Now it is housed in a small masonry chamber with a removable cover for stopping or opening the water supply to the premises. It is generally used to regulate the flow of water to the premises. Now we generally use water meter. Why we used water meter? To calculate or to measure the quantity of water supplied to a premises. Clear? Now different types of valves are generally used. We need to discuss that type of valves also, that is the sluice valve or gate valve. Now it is generally used to regulate the flow of water in the distribution system. Now sluice valve or gate valve is generally used to regulate the flow of water in the distribution system. Next one will be the air relief valve. Air valves are required to release air. What or for what purpose the air relief valve is required? To release air when the main pipe is being filled with water, or to admit air when the main pipe is being emptied. It means that air valve is required to fill the air when the main pipe is being emptied, or to remove the air when main pipe is being filled with water. Okay. Now the admission of air during emptying a pipe is very important because they will protect the pipe against the negative pressure which may develop. Okay. Now the next one is the blow off valve or drain valve or scour valve. Now generally scour valve is used to remove the sediment collected in the pipe. Now in the dead end system there will be scouring problem, so we generally use scour valve at the dead end so that we can remove the all the impurity from that portion, that is from the dead end. Okay, so generally scour valve is used to remove the sediments collected in the pipe. It is also used for inspection of pipe. Clear? Now next one is the most important valve, that is the pressure relief valve. Now suppose that this is the water main, and here you had provided a sluice valve. Here you had provided a sluice valve or gate valve. Okay. Now suppose that at the initial phase this sluice valve is open and water is flowing with very high pressure from this water main. Okay. Now suddenly you close this valve. Now suddenly you close this sluice valve. Then what will happen? Large pressure will be generated in this portion, and due to this large pressure bursting of pipe or water hammering effect will takes place. Now to reduce this water hammering effect or to reduce this water pressure, what we need to provide? We need to provide the pressure relief valve on the upstream side of the sluice valve. We need to provide the pressure relief valve on the upstream side of sluice valve. Okay, now what will happen? Just listen to me. This pressure relief valve is operated by spring mechanism. Okay. Now the weight of the spring is equals to a particular pressure which is generally kept in that water main. Okay. Now if large pressure will be generated in that water main, what will happen? This spring will move to the upward portion like this, and valve will become open, and all the water will flows from that valve like this, and valve will remain open till the pressure in the pipe reaches to a permissible value. Now, due to providing this pressure relief valve on the upstream side of sluice valve, we had just protect the water main pipe from the water hammering effect or from the bursting problem. So, valve opens automatically as soon as the pressure in a pipe exceeds the limit. It is provided on the upstream of sluice valve. It is also used to reduce the water hammering effect. We had already discussed all the possible combinations of pressure relief valve. That is all about the distribution system. Thank you very much, students.